working together.
Isn't that? Is that the? No, that's not.
Okay, everybody look over here to the sideboard. Algebra 1B, fun sock Friday, most lit day of the week. SWBA, students will be able to. The T is silent. Okay, graph parallel and perpendicular lines. We might not know those symbols yet. We're going to learn them today. Section 4.7. Okay, so we have parallel lines. Parallel lines are lines that are in the same plane but do not what? Touch. So they don't intersect is going to be our math word for it. They don't intersect, but it's that same idea. Okay? So lines that are in the same plane and do not intersect are called parallel lines. Can you guys think of real world examples that we have of parallel lines? Lines that don't intersect? Rooms, what about rooms? What lines? What lines?
Wait, okay, look at the ceiling.
Yep.
These lines ain't ever gonna touch.
Yeah, these lines, they're never going to touch each other. That'd be bad, okay? They never intersect. What about another real world example that we see?
Or the whiteboard.
Okay, like the top and bottom of the whiteboard? Okay. So you think of one?
No, I'm just looking around.
What about the flag?
I was just looking
Is there anything on the flag that could be parallel?
These parts?
Yeah, those lines, right? The stripes could be parallel. What about on roads? Do we see anything that could be parallel?
Like dots.
The lanes, right? The lanes better be parallel, otherwise you're gonna have crashes, right?
There's one like
Yes, also. Okay, boot camp. Okay.
they're driving like this and then they're like both like turning.
Yeah, that'd be bad. Okay. Okay. So we have a symbol for this. Okay, we have a symbol for this parallel lines. Okay. We do it like this. That's two slashes. And does it kind of look like it's two parallel lines there? It kind of looks like there's two lines that aren't gonna touch, like train tracks, right? Train tracks would be an example of parallel lines.
So
Okay.
I know that one. The next one's the same, right?
Yeah, parallel lines do have the exact same slope. That's an important concept here, okay? Is that parallel lines have the same slope. And here's why they have to have the same slope, guys, okay? Because if they have parallel lines, it means they never intersect. Well, here's the line, and here's the line. These slopes are similar, they're close, but are they the same? No, because what's going to happen with these lines? They're eventually going to intersect like down here, right? So they might not intersect where we draw them, but the arrow means they're going to go forever, so they're eventually going to intersect. They're not parallel. So what we need, though, is we need a line with the exact same slope, so that way they never, ever, ever intersect, okay? Because if they even just have slightly different, eventually they will. Yes?
Symbol is that like the two arrow things? Is that what the symbol is?
It's just two slashes, and what it represents is looking like two parallel lines, just without the arrows.
Alright, so it's not like one line now like going to
No, these are lines these are lines that never intersect. Yeah, so we just saw two slashes, and it's just like a mini parallel line. Yeah, thanks for asking.
Holy cow.
Now all vertical lines, so all these straight up and down lines, perfectly straight up and down, okay? Any vertical lines you have, they're going to be parallel because they're all perfectly vertical. And what slope does a vertical line have? Anyone remember? Not zero, but it's
It's unidentified.
undefined. Okay? So all vertical lines are undefined slopes, so they're all parallel because they have the same slope. All horizontal lines are going to be parallel because what kind of slope do they have?
What
They have
if defined? What if we define? So
Not the, it is a defined, but what is it? We talked about it just in the warm-up a minute ago. When it was y equals, you have what kind of slope? Tony, you remember that one? You're the one who says it. You're the one who said it. See? You have slopes of not undefined. What number is it? 0. You remember saying that in our homework? Not in our homework. You said that. Okay. So that's our topic of parallel lines. Now we're going to go through some examples here, okay? So we're going to say our goal here in example 1 is to graph a line. We're graphing a line, okay? That's what we've been doing a lot this chapter, right? It's graphing lines, okay? We want it to go through the point -2, 4. We want this to be part of the graph, okay? Gracie, what are you already doing? Plotting the point, that's a good idea, okay? She's already plotting this point. Perfect. We know it wants to go through this point. We know this point's going to be on the graph. Let's go and plot this point. -2, -4.
That's not negative.
that's fine.
Oops.
I was just gonna say.
-2, positive,
Yeah,
makes sense. Let's go and plot that point there. Okay, let's go and start there. So we want to graph a line that goes through this point. And what else are we told? It is parallel to this line. It's parallel to the line. Now what did we just say about parallel lines? They have what kind of slopes?
Undefined.
Okay, that was for vertical lines.
Why they have 0?
Parallel lines have the
Oh my.
same slope. Parallel lines have the same
This is
slope.
really bad, because they're also learning this.
Okay. Parallel lines have same slope. They have the same slope. So, we said before, if we have our starting point, typically yesterday, or 2 days ago, guys, and during our homework that we just checked, our starting point was on the y-axis, wasn't it? And then we used what to find new points?
Like one.
And what was that called? Our slope. We use our slope. So if we have 1 point, could we use slope to find more? So here's the thing. Are we told graph a line with this point and this slope? No, we're not told the slope.
But you can.
But we can find the slope because it's parallel to this line. So if it's parallel to this line, it's going to have the same slope as this line, right, Sierra? It's going to have the same slope as this line. So what's the slope of this line, Brady?
1 up over 3.
Okay. The slope of this line is going to be 1 over 3. So what's the slope of our parallel line going to be then? What do we know about slopes of parallel lines? They're the exact same. So if this slope is 1/3, our parallel line will also have a slope of 1/3. It's going to be the same concept. Let's write that down, please. Okay? Let's write down what I have here, okay? So we said the slope of this line is 1/3. That's what we're using this line for. The slope of this line is 1/3. So our parallel slope, the slope of the parallel line that we want to graph, will also be 1/3 because they're the same. So like Brady was saying, yes, we could go up 1 to the right 3. Up 1, 1, 2, 3 to the right. You just count it out there. Or we go down 1 to the left 3. Okay? Okay? So then we connect these, and what do we notice? This is a straight line? Good, good. Mine's a little baby there. Whoops. Okay. Now, just to show you guys this, you don't have to graph when I'm doing a blue, okay? So, question, Sierra, do you have to graph when I'm doing a blue?
Nope.
No, okay? So if I do this, negative, well, 1/3 x minus 3, well, I'd go negative 3, up 1 over 3, down 1, left 3. Are these the same exact line? Are they in the same exact spot? No, they shouldn't be. But are they parallel? Do we think these lines will ever touch? Okay, because we're told to make the lines parallel. We're told to make the lines parallel here, okay?
So
We're
just,
told to make the lines parallel,
so just like the opposite.
Already almost done that next.
okay? So we're told to make the lines parallel. Okay, Brady, keep the phone with please. I know, thank you, okay? So, the only reason we were given this equation, guys, we're not using this negative 3 at all. We don't care about the negative 3 for our red, which is our answer. We don't care about the negative 3. We care about what the slope is, so we can find the slope of our parallel line because it's the same. So we use the point we were given, that's our starting point now. And this is our new slope that we use. So if we try the second one, graph a line through this point that is parallel to the line of the equation, 3x minus y is equal to negative 2. So we're still asked to graph a line, and now what point are we going through this time? What point are we going through this time? 1, negative 2. So what's our first thing we're going to do? Fill in a starting point. We have to have a starting point. So we're going to go 1, negative 2. 1 is right, 2 down. We have to have a starting point there. Okay?
Would it,
Yeah.
For the slope, would it be 3 over 1?
Not quite. Because here's the thing. You went with a number that was with 3 here.
You have to make the y alone.
But you have to go y alone. Very good. Good memory there. Okay, we have to get y alone. We have to get it into y equals mx plus b to know our slope. And we're not there. Okay? So how can we get y by itself here?
We could plus 3. I mean minus 3.
Get minus 3. I like that. Divide. Minus 3x minus 3x. So what kind of y is this still?
Negative
Negative y. I can't forget that, right? Negative 3x minus 2. Let's put our x first here. So now how do we get rid of this negative 1?
You divide.
And negative 1 on the whole side. So y is equal to negative 3x divided by negative 1 minus 2 divided by negative 1. So what's negative 3 divided by negative 1?
3.
Just
3x.
And then negative divided by negative is positive 2. So what's our slope? Big picture, what's our slope of this line? What's our slope of this line? 3. Just what's with the x. Because y equals mx plus b, m is the slope. So, we know the slope of the line is 3. What is the slope of our parallel line? Parallel lines have the what kind of slope? Same. Parallel lines have the same slope. So if this slope is 3, what's the slope of our parallel line? Remember these symbol means parallel. What's the slope of our parallel line? 3. Or 3 over 1. It's the same slope. So now we have our starting point, and do we have our slope we need?
Boy.
So can we make 2 more points? And then let me.
I got it right then, okay.
So, what can we do with this? Yeah, lucky go. Okay. What can we do with this 3 over 1?
You could make this 3.
So we can up 3 to the right 1. We can plot a new point. And then can we go down 3 as well? Where should we go 1? Left. Connect those, you have a straight line. Okay? So once again, what was the only thing we used this other equation for? What was the only thing we used this equation for?
I'm slow.
Find the slope. We found the slope of this equation, because once we found the slope of this equation, we said, hey, if they're parallel, then it's the same slope.
I don't get how you got the -2.
It was already there. In this equation. Okay.
But
So-
your answer is m equals 3,
Okay.
but we never did the b.
No, here's why. Here's why, okay? So we're graphing a line that goes through this point and it's parallel to this line. We don't actually care about this line. I know this might be rude. We actually don't care about this line. We don't care where that line goes. We only care about one thing about that line, and that's the slope. That's all we care about. Because if this line's parallel, it has the exact same slope. That's part of the notes you missed when you went to the restroom. If they're parallel, they have the exact same slope.
Okay, so b. 1, 2, right.
So we had our starting point here. Instead of starting out a y-intercept with our b, we started with the point 1, -2, because we told the line goes through there. So we made that point. Because you can start at literally any point and then do slope. Okay. Okay, we're gonna pick up that calculator, so by the way. Let's go to the next page here, okay? We're going over perpendicular lines, okay? We're over perpendicular lines. So we went over parallel lines. These are parallel lines never, ever, ever touch. We said, hey, it's like the line on the ceiling. It's like the stripes on the flag. It's like railroad tracks. It's like the lanes of a street, okay? Perpendicular lines, though, perpendicular lines are going to be different. Perpendicular lines are lines that intersect at what kind of angles? Does anyone know?
90 degrees.
90 degree. We call them a right angle. It's a 90-degree angle, and we call it a right angle. It's not like right or left or right or wrong, okay? It's a separate name that just means it's called a right angle. It just means it's a 90-degree angle, okay? So something that would look like a perpendicular,
Look.
okay? So perpendicular lines would look something like that, okay? Okay, actually stop. Okay, so perpendicular lines look something like this. They intersect at a 90-degree angle. Does anyone know how we can mark that these are perpendicular? The little box there.
Oh, yeah.
Okay, that shows that it's perpendicular. Okay, do you see an example of perpendicular lines in real life? Where? Intersection of a street, right? Those are perpendicular. Where else might we see perpendicular lines? The ceiling again. We have these lines going
The floor.
the long way, and then the left way the floor. These rows on the floor between the carpet. Okay,
Not the board. Not the board.
not the board. Why not the board?
Because the frame, like the top and the bottom. I'm not talking about.
Okay, so you're saying like the top and the bottom?
Like the boards from the top and bottom, yeah.
Okay, okay. Okay, but like here, what about on this side and this side? Those would be perpendicular, okay?
Super uncomfortable.
Windows.
Okay, windows, door. So we see perpendicular lines all the time in real life. Okay?
Also, have you noticed that?
What?
Floor's pattern makes
Oh, okay. I haven't noticed it makes it uncomfortable. Okay.
Poster.
It's
Yeah.
Perpendicular board.
Okay, so we see perpendicular lines everywhere. So let's go ahead and stop carving things out now. We probably have a lot though, and I love it.
Yeah. My shoe.
Okay, no. Okay. So we have a symbol for this, okay?
I know.
So guys, here's the thing. Here's the thing. Okay? Do we want to draw all these arrows every time we do the symbol? No, it's a lot of work. And if we do this, we take the arrows off, what's that look like?
Plus.
A plus sign. So here's what we do. We cover up the bottom half, and we just do like an upside down T. So we cover up the bottom half, and we do like an upside down T. And that is perpendicular, even though you don't see it go all the way through at the bottom. Because if we just take a
little box with it too.
little box with it, see, I think that would just get a little confusing. But maybe we should in the future. You know, maybe we should consider that.
Or now. I'll invent it.
Okay.
Do math
Before my
symbol.
headphones are broke.
I'm
The
gonna
slopes
do
of parallel lines. Going back a moment, guys. The slopes of parallel lines were what? What do we know about the slopes of two parallel lines? They were the exact same.
Different.
The slope of parallel lines were the exact same. Now the slopes of perpendicular lines are going to be different, but in a very special way. Okay? They're going to be opposite. They're going to be opposite reciprocals. Okay? They're going to be opposite reciprocals of each other. Okay? Gracie, what does opposite mean?
Totally
It's the
different.
other half, but not the same.
It's
It's like
the-
yin and yang.
Okay? What's opposite mean for math? Instead of positive, it's
Negative.
negative. Instead of negative, it's
Positive.
positive. So it's the opposite sign. What's reciprocal mean?
It means like the.
Flipped over, okay?
Now we
So
flip.
the slopes of perpendicular lines are opposite. So they're positive or negative. They're opposite of each other, and they flip. Okay?
These are broke, dude.
Now, vertical lines and horizontal lines are always going to be perpendicular to each other, okay? Okay, so just like here, look up here, guys, look up here, look up here, look up here. Guys, guys.
Wait.
Hey,
Why you do that?
class,
You can't listen to
Class.
me all day.
thank you. Vertical line, horizontal line. Those are perpendicular.
It's fine.
So vertical lines and horizontal lines are perpendicular to each other. Okay, hey guys, we have three slopes here. We have three slopes here. We have 2/3, -4, and 1. We need to state the opposite reciprocal of each example. So what would be the opposite reciprocal of 2/3? 3/2, but it's what? Negative. Guys, seriously, cut it out. Thank you.
Try to learn, guys.
Okay. So 2/3, the opposite reciprocal would be -3/2. We made it opposite. Instead of positive, it's now what?
Negative.
Negative. Instead of positive, it's now negative. Okay.
Positive 4.
And instead of 2/3, we reciprocate it's 3/2. On the next one, what's -4 secretly over? 1.
Okay, so
One over
then
positive.
4 over 1.
So it's positive what over what?
Yeah.
1/4.
Sounds good.
Okay. It's positive 1/4. Stop.
Did I electrocute someone with these?
No, stop. Okay. So instead of -4/1, it's positive 1/4. We get the opposite sign, so instead of negative, it's positive, and we reciprocate it. 4/1 becomes 1/4.
Okay, so then the next one would be -1.
-1, right? Because 1/1, well, it becomes -1/1, which is the same thing as just -1, isn't it?
Yeah. So you're basically just flipping it and then changing the sign.
Exactly.
What we're doing.
Yeah, that's perfect. That gives you perpendicular slope.
So say I got like 16 over -13, then it would be what? 13 over 16.
So let's go on right below this. Let's practice this a little bit, okay? So we're going to do the same idea as what we did before, but instead of parallel, they're going to be what?
Perpendicular.
Perpendicular. Very good. Okay? So we're still graphing a line, and we're going through a point. So what are we going to do with this point, -6,2?
On it.
Plot it, right? So we're graphing a line through the point -6,2. So our first thing to do is going to be plotting that point. We have to have a starting point. 1, 2, 3, 4, 5, 6 to the left, and 1, 2 up. I already lost my count. 1, 2.
Oh, I pay for AirPods. Oh, this is good.
Because AirPods make music.
These do too. You know me here.
So they're perpendicular to, and now.
Oh my God! Guys, you forget
Can I
that
can I have your
we
attention
can
for a moment? Okay. So graph the line through this point. We made the point. Now we know it's perpendicular to this line. Now when it's parallel, what did we need this line for? We needed it for the
3/2.
we needed it for the slope, which is 3/2.
So 2/2.
Ooh, Brady's got it, okay? So we had parallel lines earlier, so we have the same slope. This time, we have a perpendicular line. Notice I'm going to do M for slope. I'm going to draw a little perpendicular in there saying, hey, this is a perpendicular slope. Brady said 3 over 2. Perpendicular would be negative 2 over 3. Instead of positive, it's negative. Instead of 3 over 2, we flip it, we bookang it, and make it negative 2 over 3. Okay, so now, how can we make more points from our starting point?
Go down 2.
Go down 2,
Or something listing.
and over through what direction?
Right now.
To the right, very good.
Yeah.
Or from this, we can go up 2 in what direction?
Left.
Left 3, okay? Goes a little bit off the graph, that's okay. We connect them, and what do we make? A straight
Line.
line.
I might switch it up though.
Yo, Brady, good work, you got that one.
Yeah, boy. I got
Okay.
it. I got it first. Thank you. Mine was still better.
Hey,
Hey, Tony, can I use one?
No.
Tony, can I use one?
What? Yeah, that's crazy if you wanted to try earlier, but no one else can. Wow, okay. I see how it is.
You'll probably take it.
See if I give you a quarter again.
Look, it's really like
After I gave you a quarter for you,
So bring this on.
Oh.
You didn't give me a quarter. You gave Kate a quarter. Yeah, actually.
Yeah. I thought I gave you, oh, you never quarters yet.
Oh, yeah.
You're right. After I complimented your phone.
Wow.
And I
Hey.
complimented yours too.
Unbelievable, brother.
Okay, pay attention up here again. Recap what happened here, okay? Let's recap what happened here. We grabbed the line through the point.
Some cap right there. They know you were.
Nice.
That's good.
They say they weren't.
That's because they are.
They are working.
We grabbed the line through this point,
Yeah.
negative 6, comma 2, that's our starting point. Then we had to have it perpendicular,
Yeah.
so we needed the slope. We need perpendicular slope. Okay. Oh, but I can't use them?
I didn't tell Brady that.
They worked up there. I just had to make sure they do.
Dude, they got so
That's
much
right.
space,
We're
bro.
officially working.
No, the AirPods, bro.
You can't, I just want to
You
be
just
cool,
have to.
okay?
You have to have a good imagination.
I just want to be with the cool kids. Like SpongeBob, Patrick, and they do the box, okay? Okay,
Imagine.
Ready? When it
number
goes-
4.
So that was our answer.
The line. Okay, the line was our answer. On all of these, the line is our answer. Okay, on this one, graph the line through 2, comma 1 as perpendicular to the other line. What are we trying to do? What's our end goal? To graph a perpendicular line. Where is this line going through?
2-1.
2, comma 1. So what's our first thing we're gonna do?
I say.
What's the first thing we're gonna do?
Put it down.
Put it down.
Plot 2, comma 1.
Kill it.
Can we not say put it down?
Put it down.
You can't, it's weird.
Assassinate it.
Don't die. Okay, same.
She needs to know. She started
Okay.
crying.
So, now what do we know about the slide? It's going to be parallel to it or what?
No, it's gonna-
Perpendicular. So, what do we need this line for? What do we need this line for? What good is that for us? Not good.
It is good.
What do we need from that line? We need something from that line.
We need that. Get that big cloud. M.
We need the M. What's our M? It's our
2x.
slope. So we need our slope. But is this set up for our slope already?
No.
No, okay. So what do we need to do to get our slope from 2x minus 3y?
Get Y alone.
Okay, we need to get y alone. So we don't want to move 3y. If we're trying to get y alone, subtract 2x. Tony, Kane, are you doing this with me? I don't think so.
I wonder.
So we have negative 3y is equal to negative 2x plus 3.
Did you say you wonder how we're gonna grow up?
Yeah.
We're gonna be like SpongeBob and Patrick. Kid goes up through the rock.
Okay, buddy.
Okay.
Alex
So,
Squidward's house.
If anything, well, how do we get negative 3 away from y now?
Divide.
Both sides.
Negative.
Y is equal to negative 2 over negative 3
Which is
x plus 3 over negative 3. Okay? And yeah, negative divided by negative is a positive, so 2/3 x. What's positive 3 divided by negative 3?
Negative 3.
Negative
1.
1. So, big picture, what's our slope of this line?
2 over 3.
Negative 3
So, our perpendicular slope, what we really want is negative 3 over 2.
Red. That's a lot.
I know. If you didn't pay attention while I did it, it would make more sense.
I'm thinking my AirPods are gonna be.
So then we'd go like
Did you watch these two?
down 3 and then over 2.
We'll go over that one second. Let's slow down for a second. Let's take a breath, okay? Let's refocus on what we just did, because I have a feeling we missed some of that. Okay? Or I'm feeling we need to hear something again. Okay?
No, I got it.
So after we had our starting point,
I got it.
we needed to define slope. Well, in order to find our new slope, we need to find the old slope and then change it because it's perpendicular. We had to find the old slope by solving for y. So we went through, solve for y, found, hey, this slope is 2/3. Our new slope, as Brady said, he copped it. He said, hey, we're going to opposite, instead of positive is negative, we're going to reciprocal, 2/3 becomes 3/2. So now, from this point, where could we go to make another point? Down 3, right 2. Very good, Brady.
Ooh.
Or from our original point, where else could we go? Instead of down 3, we could go
Up 3 over
up 3 and over to what direction? Left. And what do we notice? These make a straight line.
When we go on that little break, can we go to the bathroom? Like before we go upstairs or anything?
Because we're almost done.
'Cause I'm about to explode.
Can we go to Miss Poppins?
No, she has a sub, she's not here.
Mr. Westling, no.
No, we're not gonna. Okay.
Probably not.
Okay, let's go on to the next one, guys. We have 2 more examples and we're done, okay? Can we dial it in here? Can I ask you guys that?
Yeah.
Can we dial it in here for these 2? Okay. So, we're asking here, are these 2 lines parallel, perpendicular, or neither? We're asked to explain. These 2 lines on number 1. This should be a 1/2, by the way. That printed terribly on yours. If you guys can fix that.
Those are parallel first. Literally looks like a pair of sunglasses next to a juice box.
Yeah.
Okay, we're on the very bottom of that page.
It looks like
Whoa,
sunglasses with a
dude.
juice box.
I know. It copies the 1/2 weird. It's a 1/2 x. Okay.
Sunglasses with a juice box.
So guys, listen up. Listen up. What do we know about parallel lines? Their slopes are the same. Perpendicular lines, the slopes are the opposite reciprocal. Neither would be literally anything else. So how could we figure out what these lines are? We'd have to look at their what? Slope. So what's the slope of this first line?
I like how you're staying on that chair.
You can drive front
What's the slope of this line?
2x.
Try again.
Negative 2.
-2. Because this is already in, guys, we're going to focus up here. And this is already in y equals mx plus b. So the m is whatever's with the x. So what's the m here? -2. What's the m here?
1/2. So no.
What do we notice? Are these parallel? Are they the exact same? Are they opposite reciprocals? Brady's saying yes. This one's negative, this one's positive. 1/2. This is secretly 2/1. So these are perpendicular. Now we can write out the word perpendicular, or we can do the symbol.
Or we can put per.
Or we're going to put per, okay? And what does it say? It asks us to explain. So what's our explanation? How do we know these are perpendicular? Because they are
Opposite.
opposite and reciprocal, right? So they're perpendicular because they are opposite reciprocals. Please write that down with me, okay? We need an explanation here. It asks us for an explanation, we're going to give an explanation, okay? That's why they're perpendicular, because not only are they opposite sign, they're also the reciprocal. They have to be both. Okay? So we had to look at the slopes to know what they were. On the second one, we have 2 more lines. Once again, we have to look at the slope. But here, are these set up to look at the slope right away?
Yes.
No.
No,
No.
you divide.
We have to get y by itself. So let's look at the first equation. 3x is equal to 2y minus 6. How do we get y by itself here?
Both sides.
Add 6 to both sides. I like it. Okay? 3x plus 6 is equal to 2y. Now what do we do to get y by itself?
You divide 2 over the rest of it.
On both sides, yeah. So we have 3/2x plus 6/2 is equal to y. So 3/2x plus 3 equals y. So what's our slope here? Okay, it would be 2, no, not 2 over 3. Our slope
Wait, I
is,
can't see it.
I know, I'm pulling up here. There we go. So here, what's the slope of this line?
-2 over 3.
That'd be the perpendicular one. What's the slope of this line right here? 3/2, the one that's there. Okay, so that's the slope of this line.
And the perpendicular would be 2 over -3.
If it was, yep. And so if we get that, it'd be perpendicular. Okay, so now what we need to do, we found the slope of the top line. Now we need to find the slope of this bottom line. 9y minus 6x is equal to 3. How do we find the slope of this line? Solve for
Same thing.
y. So what do we have to do first?
Plus 6x on both sides.
Add 6x to both sides, and then we can do that stuff. 9y is equal to
Really?
6x plus 3.
You're higher from that.
Okay,
Guys,
boys, figure it out. So now, Tony, what do we do? Divide by 9. There you go.
Okay, so it's
Okay.
y equals 3 plus 9, 36.
Thank you so much.
Lucky that's not top, that would have told me. Like snake you.
That was who? Who?
Hot.
Who?
Hot.
Oh, I know who you're talking about. I was confused. Okay.
Y
Y is equal to 6x over 9 plus 3 over 9. Can 6
Y
over
equals-
9 reduce?
No.
What
No,
goes into
yes.
both 6 and 9?
Yes, yes, 3.
So it becomes 2x
2 over
over 3. What does 3 over 9 become?
2 over 3. X plus
What's that number under that?
1 over 3.
Okay, okay.
So what's our slope of this line?
1 over 3.
Do it.
So we have the slope, one slope was 3 over 2, one slope was 2 over 3. So are they the exact same? No, so they're not parallel. Are they opposite reciprocal? No.
Neither.
They're reciprocal, but are they opposite? No. So it's not parallel, it's not perpendicular, so what's it have to be?
Neither.
Neither. Neither, whatever you want to call it. So they're neither, and our explanation is that they're not the same. They're not the same, and they're not opposite reciprocal.
Kid, were you there that day we tried to sneak into that freaking football pool?
Yeah.
Okay? That could be our explanation. So once again, we had to find the slopes in order to know what to do. Okay, guys, I'm going to pass out our homework. Okay, I'm going to pass out our homework here.
anytime they bring up crazy stories, I start hearing like the Life of Jack and Cody.
Rachel's
Song
got it.
coming in my head.
We were close.
Really?
Yeah, bro.
We walked in the hook,
The way
Guys,
he was looking at
Yeah,
us.
there's a guy that walked out, but we were in the bathroom.
We would've got in there too. We would've
Got
been
caught?
Where was this hut? It was, so you know the Holiday Inn by McDonald's, at the gas station, all that building? Yeah, it's.
By Cornhusker? Like on,
Yeah,
like
it's like
Walmart?
on Cornhusker by like Walmart or whatever, Holiday Inn.
Okay, hey guys, real quick, on this worksheet, okay?
Oh,
On this worksheet, here, can I see yours? Okay, the front side, guys, what word is underlined in each of those problems? Okay, parallel. On the back side, what word is underlined on each of those?
Perpendicular.
Okay, so on all of these, so on the front, they're all parallel, on the back, they're all perpendicular, and they're like a lot of the problems in our notes, okay? If you need help on this, what could you guys do?
Call you.
Ask me, what else could you do?
Call you.
Look at notes, what else could you do?
What's
the partner.
Watch a video later.